the questions referred to this guy, introduced a new function, actually introduced a new pair of functions. Believe it or not, this is pronounced cosh x. And I think from memory, they define it as being e to the x plus e to the minus x on 2. Does that sound about right? I think it's like question 13 or 14, something like that. Okay. Cosh x has a brother named, believe it or not, Sine x. I didn't make it up. That's how they pronounce it. Mathematicians, whatever. Okay. Sine x. Now, you're like, what? Like these textbook authors, they're just making stuff up, you know. It's just, no, they're not. If you have your calculator there, right there in the middle, next to sine, in fact, you'll see a button which says hype. Hype. Is there any guesses what it stands for? It stands for hyperbolic. Now, if your calculator's on, and you are, excuse me, if you press the hyperbolic button, up appears a whole bunch of functions, 2 of which include cosh and sine. Okay, so I'm going to explain very briefly what these two are and show you what they look like. Do you need to know them? No, I met them at university level maths. Where did I learn them? Maybe differential calculus. I can't remember, honestly. But you don't just learn stuff because you have to. Learn stuff because it's cool. And these guys are cool. Now, here's the question for you. Just have a look at what they are. They're built off exponential functions. Okay. Why are they called what they are? They're weird names. They have nothing to do with trig. Do they? Now, I want you to have a think about why might they have called them, you know, cosh and sine. They are pretty ridiculous names, so they obviously had to have a good reason for them. Okay. Let me ask this first. All of these functions have a kind of symmetry, right? You guys know about different kinds of symmetry. There's 2 main types. What kinds of symmetry do you see for cosh? What kind of symmetry does it have? Look at it, think about it carefully. If you can't see it right away, then maybe you should do what I do and graph. People hate graphing, don't they? But it's such a good diagnostic tool, such a good thinking tool. Okay. What does this guy look like? E to the x, we know what that looks like. It looks like this. What does e to the minus x look like in comparison to that? Same thing, but it's been flipped horizontally, yeah? So, okay, let's see how I go. Something like, haha, I got it. I'm not going to do that the next 100 times. Oh well. Okay, so there you go. That's what e to the minus x looks like. We're going to add them up, and then we're going to halve them. Now, immediately, even before I add them, you can probably see what kind of symmetry you're going to expect. It has a name. You're adding 2 things together, which are mirror images of each other across the y-axis, right? So what kind of symmetry will you get? This is 1, isn't it? Y equals 1. So you're going to add them up, you get 2, but then you're halving it. Okay, so you're actually going through here. What's happening over here on the right-hand side? Okay, let's just actually consider it without the 2. You're going to be here. There's 2 and 1. Okay, what happens as you approach infinity? You're going to be approaching this. You're actually asymptotic to e to the x, right? You're never going to cross it though. Why not? You're always adding something. It is getting smaller and smaller and smaller, but it's never 0 and it's never negative. Okay, so you're going to approach, but never quite get there. Okay, the same thing's happening on the other side, just in reverse. Okay, so you're getting this kind of shape. So now you take that and you halve it. Okay, so I guess it'd be something like this. I don't know. It's roughly. Okay, so there you go. That thick-looking guy in the middle there. That's cosh. What kind of symmetry does it have? It has even symmetry, right? Even symmetry. What kind of symmetry does cosine, regular cosine have? That's interesting. Also even symmetry, right? I won't complete it for sine, okay? I'll just draw it in for you. Sine looks like this. Okay? When you subtract instead of adding. Okay? Now there's one other key similarity that sine and cosh have to their non-hyperbolic cousins, right? And it's actually the subject of the question. So when you differentiate sine, okay, what do you get? right? You differentiate e to the x minus e to the minus x on 2. So what happens to the e to the x? You just get e to the x. What happens to this guy? It's chain rule. The derivative of the inside function is minus 1. Okay, so that comes out the front. And oh, that's interesting. Another similarity. Now there are more than that. I'll let you go, and if you're curious, you can go and research hyperbolic cosine and hyperbolic sine. But that's what it's about. I didn't think, what am I reading? What am I even doing? Okay, this is what they're talking about.